Hello statistics students, the purpose of today's lesson is to find the equation of the least squares regression line for bivariate data. Now before this you were probably working with only one variable, and now we are going to be working with two variables, hence the bi in bivariate. So what you need to know is that for bivariate data, the way that we plot our data is on a scatter plot. So we plot the x values on the x-axis and the y values on the y-axis. And if the data shows a linear relationship between x and y, then the line that best describes the linear relationship is called a least squares regression line. And what a least squares regression line is the line through the data points that minimizes the sum of the squares of the residuals. And this is the line that I drew in this scatter plot. And that's the point that minimizes the distance between the actual data points and the predicted data points. So how do we know if a least squares regression line is appropriate to use to create a linear model? Well, the first thing that we would look at would be the scatter plot of the relationship between x and y. So we can see that the relationship is linear, positive, and pretty weak in strength. Now if we look at the residual plot, we have to note that there is no obvious pattern in the data points in the residual plot. If there were a pattern, we would be able to say that the original data would not be linear, therefore we would not be able to use the least squares regression line to predict the relationship between x and y. So how do we find the equation of a least squares regression line? Well, you may be familiar with y equals mx plus b, the slope-intercept form, something we've all learned. Well, hopefully. So you have your y value, your x value, your slope, and then your y-intercept. But in AP statistics, we have your predicted y value, or your y hat, equals a, which is also your y-intercept, your predicted y-intercept, plus bx, with b being your slope. So, the equation to find the slope is b equals r times sy over sx, which is the standard deviation of y over the standard deviation of x, times the correlation coefficient. And you should know that from earlier lessons if you've watched any of Hedstrom's videos. And in order to find the value of the intercept, so a equals y bar minus b, which is your slope that you just found, times x bar. And if you are given data, you can put in your calculator into list 1 and list 2 and then go to second vars and find the values of x bar, y bar, r, sy, and sx. So the 5 variables that you will need is the standard deviation of y, standard deviation of x, y bar, x bar, and the correlation coefficient. Okay, so now for an example. Can the fat content of a hamburger predict the number of calories it contains? The table below shows the fat content and corresponding number of calories for burgers from several different fast food restaurants. Summary statistics are provided, so you don't actually need to put your data points into L1 and L2 and find all of the different variables. Now you just need to base your answer off of the given data. So for your fat, that is your x value, your explanatory variable, and then your y is your calories, which is your response variable. So you have y hat equals a plus bx, and then you have to solve for your slope. So if b equals r times standard deviation of y over the standard deviation of x, all you have to do is plug in the data that they gave you into your equation to find b. So b equals r 0.9606 times the standard deviation of y, and you can see that this is y and this is x because this is the calories and this is the fat. So you have 0.9606 times 89.81 over 7.8. And that gives you b equals 11.056. Now we need to solve for a, so a equals y bar minus b times x bar, and that's given to you in the problem. So a equals y bar equals 590 minus b, which we just solved for, so that's minus 11.056, times x bar, which they also give to you, it's the mean fat, which is 34.286. So a equals 210.954. So now that we have b and a, we can solve for the least square regression line equation. So now we have y hat, which is the predicted y value, equals 210.954, which is your a, plus b, 11.056, times x. So now that we have that equation, we can also write it in context. So we have the predicted calories, since the calories is your y value. So you have the calories hat equals 210.954 plus 11.056 times the grams of fat. Okay, so example number 2. The Great Plains Railroad is interested in studying how fuel consumption is related to the number of rail cars for its trains on a certain route between Oklahoma City and Omaha. So we have our x and y values, which is number of rail cars and fuel consumption respectively. And then now we have, let's go to the first question. So is the linear model appropriate for modeling these data? Well, let's look at the original data plot. So we can see that it is linear. And then we can also look in the residual plot and see that there is no obvious pattern, so a linear model is appropriate to use. So now let's go to B. Find a linear model and write your model in the context of the question. So our least square regression line equation is y hat equals a plus bx. Now let's solve for B. B equals r times the standard deviation of y over the standard deviation of x, and we don't have r itself, but we have r squared. So r squared is given to us as 0.967, and the square root of that is 0.983. So b equals 0.983 times the standard deviation of y, which is given to us as 22.7635. And then we also have the standard deviation of x, which is given to us as 10.4158. And if we solve for that, we get b equals, once I put that in my calculator, I get 2.149. So now I have to solve for a, and a is y bar minus b times x bar. And y bar is given to us as 87.2 minus b, which was just used, so that's 2.149, times x bar, which is 35.6. So once we put that in the calculator, a is equal to 10.696. So now that we have A and B, we can put that in the equation for the least squares regression line, which is y hat equals 10.696 plus 2.149 times x. And if we want to put that in context of the question, we know that our y value is fuel consumption and our x value is the rail cars. So we have fuel consumption, the predicted fuel consumption equals 10.696 plus 2.149 times the x value, which is the number of rail cars. So that is it, and I hope you enjoyed the lesson. I will see you later. Goodbye.